Thank you all the brave people that are still here watching our Quickfire pitches. I'm Lucas. I'm a last year PhD student at ETH Zurich, and I will guide you through the last 4 years of my life trying to answer what seems like a very simple question, but I learned it's not as simple as I thought. So the problem that I'm trying to deal with is the fact that cities are getting hotter and hotter, as you are very much experiencing in Singapore at this moment. And trees and water can really help cool the cities down. Just a raise of hands who went to see this thing in the airport. And who went to see other green areas in Singapore in the last few days. So when I did this presentation, I thought that I would have seen this in the airport before, and I was going to say like, yeah, you should go there and see it because it's really amazing, but I didn't go there yet. But it's really nice, and it uses trees and it uses water also to cool down the place. But the big problem that I found in the end is that heat affects different populations in different ways, and that's what I ended up focusing in my PhD. So the very simple question that I've been trying to answer in the last few years is this. So where should we plant trees in the cities, given that we know that trees help cool cities down? And I'm going to try and convince you in the next 4.5 minutes or something that it's a matter of urban physics, so us finding the opportunities in the city, so where are the places that we can get the best cooling from these trees, and it's also a matter of identifying the populations at higher heat risk in the city. So if we manage to find a balance between these two things, we found the best places for planting trees in a given city. And what we did, we started with Zurich, which is where I'm based and where we have a lot of data. And first thing was to actually find where trees fit. So where is there enough space for trees in the city? Meaning that if we find more space available, we can plant more trees. And if we can cluster together those trees, we can get the best cooling out of this. We also understood that it's a matter of water. So I had to squeeze some sort of water because I'm based in a water-related institute, so I had to put some water somehow. And more water means more cooling because trees can use that water to evapotranspire and do some evaporative cooling as well. So if we can find the places where you already have more water in the city and actually plant the trees in that specific spot, we found that it was going to be a good thing, so we put that in the model. And also different built environments in the city will create different tree cooling behaviors. And then in heat risk, I think this is the most interesting part of what I learned because I'm an engineer and then risk is more of a social thing as well. So for me, it was a lot of stuff to learn. So we need to look into not only where are the places where you have the highest heat stress, which is the hazard itself, but we also need to look into the frequency of that hazard. So if we have some hot days, but they are very sparse, it's not really a big deal. And we also need to look at who are the people and where are the people that are actually exposed to the hazard. So if people are actually within the heat hotspots in the city. But most important of all, we also need to look into vulnerability. And vulnerability is not a thing that a person is vulnerable. It's not an inherent thing, so the person is experiencing vulnerability. So it's not a vulnerable person, but there is a person experiencing vulnerability. And that's because we can have some capacity to adapt to that risk. So for example, at this very moment, we're adapting quite well to heat because we're using some air conditioning and we're actually not under heat risk at the moment because we have the means to overcome the adverse impacts of heat. And also people can be sensible to heat. So elderly people or a woman in menopause can be more affected by heat naturally as well. So what I've been trying to do is to merge these two things together and understand that engineering is not only about technology, but there's also an ethics element in what we do. So if we think about planting trees, there's also some ethics involved in where we're going to actually put those trees. So if we think about this in a distributional justice way, we need to distribute trees in a manner that we actually put those where the people are that most need those trees. We also need to prioritize planting trees such that we fully mitigate thermal stress, ideally, and also recognize groups at high heat risk. And we also need to involve those people in this process. And these are some results very quickly before I wrap up. So what we found was that if we increase 5% of Zurich's tree canopy, we could fully neutralize the heat stress of 27,000 people at high heat risk. But if we actually irrigate those trees, and in our model, it really pinpoints the places that we can add trees. I ended up coloring this in pink, but it would be nicer to color it in green so that you understand that those are trees. So each of those small hexagons are trees. And then with water, we rise that to 78,000 people protected, which is 17.5% of Zurich's current population. And on an average summer day, what we wanted is that if we increase the number of trees and increase water, we take people from the red area, so from the thermal stress areas, and move them down to the blue areas. And we actually managed to do that in most areas of Zurich for an average summer day. But for an extreme summer day, we actually didn't manage to do that. So you can see that there are no parts there in the blue on an extreme summer day, which doesn't mean that we don't have to plant trees, but probably they're not going to create enough protection for extreme summer days. So to wrap up, where should we plant trees to cool down our cities? So I hope that you can see this as now quite a bit more complex thing to do. Involves urban physics, involves heat risk, involves what we're calling now thermal justice, and we shouldn't forget the water. So I thank all my supervisors, the Swiss National Science Foundation, ETH Zurich, my colleagues as well, and also you, and I'm open for questions. Thank you very much.
Hi, thanks a lot for this great talk. You mentioned several influencing like risk factors and these other factors. Can you speak a bit about the journey to narrowing it down to those like 4 influencing risk factors, for instance? Like how did you get to those?
Yeah, I just very simply used IPCC risk assessment, so International Government of Climate Change. And they divide that into that. Just the hazard element, they don't divide, I think, with the frequency, but they just associate hazard with frequency. And I just decided to divide that, but it was just IPCC.
Yeah. All right, thanks.
Thank you.
Hi, thanks for a really interesting and relevant talk.
Thank you.
I have 2 questions. One is, when you talk about the built environment, do you take into account, for instance, bus stops where people spend more time and very often it's a vulnerable population?
Bus stops, you said?
Yes, bus stops, because it's a lower income population very often, older people. And the second question is, do you know how this modeling translates to hotter cities in lower income countries?
Thank you for the questions. So yeah, for the exposure, we only use residential areas. So where are the people actually living and not where they are staying. So this is the next step on my research, actually make it dynamic. So not only look at where people are living, so mostly where they're actually spending the night and not outdoor time, but also look into where they're going. So a master's student with us, she looked into mobile phone data and actually where people were going to work, for example, and then using bus stops and this sort of stuff. And yeah, that could help to make this more dynamic and like a static data. And the second question that you asked were like more to the global south. Was that it?
Do you know how this modeling translates into exactly global south and hotter cities?
Yeah, yeah. For me, that's the topic of my postdoc proposal that I'm writing now. Because I come from Brazil. I'm doing this work in Switzerland, and Switzerland has lots of data and everything is amazing. But yeah, when we try to translate this to Brazil, for example, like it's not that easy. So I looked into informal settlements, so what we call favelas in Brazil. And just the space analysis that I did, for example, that wouldn't even apply for a slum because you just don't have enough space to plant a tree. It's just not there. So we looked into green roofs, so vertical gardens and stuff that Singapore is really good at. So yeah, those could be like other alternatives. But yeah, those are scenes for the next chapters.
Great, thank you so much.
Thank you.